looking at number 9. Number 9 says, what are the values of the test statistic Z for the two outcomes in the anemia study in exercise 15.1? I have 15.1 up here for reference. The X-bar values that were available in number 1, I think you can find this in 1B if you look in there, where X-bar equals 11.3 and X-bar equals 11.8. So those are the two outcomes that they mentioned in that study. The test statistic Z is what we need to calculate. Now Z is always how many standard deviations you are from the mean. So from our picture here, it looks like we're going to have something around -1 for Z because it's one standard deviation to the left, and another one that's approximately -3. So that's ballpark what we should be looking for based on the graph we drew in an earlier problem. We have the mean that we calculated of 12 and the standard deviation of approximately 0.23. The formula for calculating Z is going to be Z equals our X bar minus mu, so the difference between the X value that we found and the mu that we're given, and that's going to be divided by the standard deviation, which we always remember when we have multiple things being averaged together is sigma divided by the square root of n, not just sigma. So this 0.23 already accounted for that because we already did that on the previous problem where we calculated 1.6 divided by the square root of 50 equals 0.23. So let's go ahead and figure out what it is for these two numbers. First one, we take our 11.3, we plop it into the formula for X bar. Mu we know is 12, standard deviation was 0.23, or if you want to be more exact, you could type in 1.6 divided by the square root of 50, and that's going to give you something close to -3.09. So the Z-score here is -3.09, which is going to be the same thing on this normal curve if this was a standardized normal curve. For the next one, for our Z, we calculate it with 11.8, so we plug in 11.8 on top minus 12, divide that by our standard deviation, and we're going to get -0.88, which is, again, pretty close to -1, which is what we expected. This one was pretty close to -3, which is what we expected graphically. So that's how you calculate the Z-score. You're just finding how many deviations away is it from the mean.